Space exploration has always been a frontier of human curiosity and technological prowess. Among the many missions that have expanded our understanding of the cosmos, the Soviet Phobos project stands out as a tale of ambition, ingenuity, and the challenges of interplanetary travel. In the late 1980s, the Soviet Union embarked on an ambitious mission to study Mars and its enigmatic moon, Phobos. This mission, known as the Phobos project, aimed to push the boundaries of space exploration and gather unprecedented data about our neighboring planet and its satellite. The project consisted of two spacecraft, Phobos 1 and Phobos 2. Launched just 5 days apart in July 1988, these probes were equipped with advanced scientific instruments designed to study Mars's atmosphere, surface, and Phobos itself. Phobos 1, the first of the two probes, was launched on July 7, 1988. It carried a suite of instruments aimed at conducting detailed observations of the Martian environment and Phobos. The scientific payload included cameras, spectrometers, and sensors designed to analyze the planet's atmosphere and magnetic field. However, the mission encountered a critical setback. On September 2, 1988, communication with Phobos 1 was lost. The failure was traced back to a software error, a missing command that led to the deactivation of the spacecraft's attitude control system. As a result, Phobos 1 lost its orientation, rendering its solar panels unable to generate power, and ultimately, it was lost in the void of space. Undeterred by the loss of Phobos 1, the Soviet team pressed on with Phobos 2, launched on July 12, 1988. This probe carried similar instruments and additional landers designed to make contact with the surface of Phobos. Phobos 2 successfully entered Martian orbit and began its scientific operations. The spacecraft returned a wealth of data, including detailed images of Mars and Phobos, and conducted several experiments that provided new insights into the Martian environment. Among the most notable achievements of Phobos 2 were the close-up images of Phobos. These images revealed the moon's irregular shape, cratered surface, and mysterious grooves, features that continue to intrigue scientists today. Just as the mission was poised to deploy its two landers on Phobos, disaster struck. On March 27, 1989, contact with Phobos 2 was abruptly lost. The exact cause of the failure remains unclear, though it is speculated to be due to a malfunction in the spacecraft's onboard computer or possibly a collision with an unknown object. Despite this abrupt end, Phobos 2's mission was not in vain. The data it transmitted back to Earth enriched our understanding of Mars and its moons, and the mission provided invaluable experience for future interplanetary endeavors. The scientific payloads on both Phobos 1 and Phobos 2 were designed to explore various aspects of Mars and its moon. These included spectrometers for analyzing the composition of the Martian surface and atmosphere, magnetometers to study the magnetic field, and cameras for capturing high-resolution images. Spectrometers on the probes analyzed the light reflected off the Martian surface and Phobos, allowing scientists to determine their composition. The magnetometers provided data on the magnetic environment around Mars, which is crucial for understanding the planet's geological history and its potential to support life. The Phobos project was part of a broader Soviet strategy to assert its dominance in space exploration during the Cold War. Despite facing significant technical and financial challenges, the Soviet space program made remarkable strides, from launching the first artificial satellite, Sputnik, to sending the first human, Yuri Gagarin, into space. These early successes set the stage for more ambitious missions like the Phobos project. However, the complexity of interplanetary missions presented new challenges. The harsh environment of space, coupled with the vast distance between Earth and Mars, made these missions particularly difficult. The loss of Phobos 1 highlighted the critical importance of software reliability in space missions. A single missing command in the software led to the spacecraft's failure, underscoring the need for rigorous testing and validation processes. Phobos 2 faced its own set of challenges. As it approached Mars, it had to execute complex maneuvers to enter orbit and begin its scientific operations. The spacecraft was designed to withstand the harsh conditions of space, including extreme temperatures, radiation, and micrometeoroid impacts. During its operational period, Phobos 2 made significant contributions to our understanding of Mars and its moon. the spacecraft's instruments provided detailed images of the Martian surface, revealing features such as volcanoes, canyons, and evidence of past water flow. The images of Phobos captured by Phobos 2 offered new insights into the Moon's composition and surface features. Scientists were particularly interested in the grooves and crater chains on Phobos, which raised questions about the Moon's geological history and the possibility of past collisions with other celestial bodies. One of the most ambitious aspects of the Phobos project was the deployment of landers designed to study the surface of Phobos up close. These landers were equipped with instruments to analyze the Moon's soil and structure, providing a better understanding of its origin and evolution. Unfortunately, the loss of contact with Phobos 2 occurred just before these landers could be deployed. The exact cause of the failure remains a mystery, but it is believed to be related to a malfunction in the spacecraft's onboard computer or a possible collision with an unknown object. The Phobos project stands as a testament to human perseverance in the face of adversity. It highlighted the complexities and risks of space exploration and paved the way for future missions to Mars and beyond. Today, space agencies around the world continue to explore Mars with advanced spacecraft and rovers. These missions build on the legacy of the Phobos project, using more sophisticated technology and benefiting from the lessons learned from past missions. As we look to the future, the legacy of the Phobos project reminds us of the challenges we must overcome and the incredible discoveries that await us in the vast expanse of space. Thank you for joining us on this journey through one of the most fascinating chapters in space exploration history. Be sure to like, subscribe, and stay tuned for more exciting stories from the final frontier.